So we have a lot of material to cover here. I'm going to talk fairly fast, and there's a lot of hyperlinks in these slides. So I will encourage you to go download these. They're going to be on the ATO site after sometime the next couple days. So go get them, and there's lots of links in there that you can click and go find out more information. There's a whole lot of stuff to cover here. So like I said, we'll go pretty fast. Brief introduction, my name is Mark. I work at Cisco. I've been working in the OpenStack space for several years now, and I do a number of things related to OpenStack at Cisco with our various customers, as well as some other stuff around massively scalable data centers, big data, and a few other topics. So I've had various roles at Cisco in the OpenStack space. Got started in OpenStack in around 2011. So my first design summit was the Diablo Summit in California, and I've been to every one ever since. And as soon as I get done here, I have to go figure out what to put in my suitcase for Paris in 2 weeks for the next one. So the fun thing about OpenStack is that there are a whole lot of use cases, and you get to explore a whole lot of things outside of just cloud itself, and we'll talk a little bit about that later on as well. And also I get to build a whole lot of different clouds of all different sizes. So we have customers who want to build clouds that are no more than 3 servers. And then we have others that want to build like hundreds. So it's a pretty fun bag to deal with. This is not going to be an overly formal talk. Feel free to shout if you don't understand something, and I'll try to get around to you. Just know that we do have a whole lot of stuff to cover here. You can always find me afterwards. I'll leave everybody my Twitter handle and email address and all that kind of stuff. So feel free to hit me afterwards as well. This is pretty exciting for me. I've been doing OpenStack since 2011, and this is still what gets me up in the morning. So hopefully you'll get a little sense of that as we move through here. So fortunately, in the OpenStack space, there's a whole lot of smart people working on this project. These are some of the contributors that I've worked with at Cisco, and some of the early PTLs from the OpenStack community, some of our OpenStack board members, some more contributors, some of the newer PTLs. It turns out to be a whole lot of people. Every time I do one of these talks, I have to update this part of the slide because these numbers keep changing on me and they keep going up. So keep in mind that OpenStack now is just a little over 4 years old, and there are almost 17,000 members of the OpenStack Foundation. So it's a big number. They come from 145 different countries all over the world. There's over 20 million lines of code in the project itself, and there are over 429 IT companies, customers, and deployers who have signed up as supporters of OpenStack. So this is kind of a big deal. That doesn't usually happen in that small amount of time. So what is OpenStack? There's a definition that I pulled off the openstack.org website, which you are free to read at your leisure. But basically, it is software that runs clouds. And that includes services like compute, network, storage, security, all those things that you need to actually build a cloudy environment. And it's also the community behind that software. And that's actually pretty important to understand, that OpenStack is not just a piece of software. It's actually very community-centric. And we'll talk a little bit more about what the OpenStack community looks like. So first of all, let's talk a little bit about cloud and why cloud is becoming such a big deal. So these are some numbers that are pulled from IDC a couple years ago. And people kind of realized that over time, operating expenses in their data center were really starting to eat into their cost. It wasn't really just the cost of buying hardware anymore. It wasn't really the cost of buying software anymore. It was the operational expenses that were really driving up the sort of total cost of ownership. So things like, in the old days of virtualization, you had to open a ticket, get somebody to rack a server or spin up a VM for you, and there's kind of this long turnaround that involved a lot of human beings in the process. Somewhere along the line, cloud computing came around, and all of a sudden you could do things on demand as a tenant much faster. So that's part of what helps drive down OpEx in the data center. And OpenStack is kind of one of the answers to that problem. So a little bit of community history. OpenStack was founded in July of 2010. The 2 original contributors were NASA and Rackspace Hosting. Basically, NASA had gotten together an internal platform for doing cloud in a project that they called Nebula. And that is the code that actually became the compute engine behind OpenStack today. Rackspace, around the same time, was developing a new object storage service, which is what we know today as OpenStack Swift. The two kind of got together and realized that they were doing the same things and both wanted to do open source, that these were pretty complementary projects, so they launched OpenStack. By a few years later, we actually had the OpenStack Foundation formed as kind of the independent overseer, so that it was not under the control of any one given company, but actually in the hands of a nonprofit foundation, including all the software assets and the trademarks and all those kinds of fun things. The 10th release of OpenStack is just out as of a couple weeks ago. So released on October 16th. OpenStack has a 6-month release cycle. So every 6 months you get a new release of OpenStack. It's still a pretty young project, so in 6 months, a lot happens. We'll talk a little bit about that as we go here. So over 429 companies are official supporters of OpenStack. There's a lot more that actually either are deploying OpenStack or are doing other things to support their products on top of OpenStack or below OpenStack. There's kind of a smattering up here. I tried to throw a couple of buckets up there just to give you a sense of the sort of breadth of the community here. The OpenStack community includes everybody from equipment vendors to software makers to telcos to enterprises. So it's a pretty large and diverse bunch. As far as governance and structure goes, the OpenStack Foundation is the nonprofit body that I mentioned earlier that oversees kind of the intellectual assets of OpenStack. OpenStack itself is licensed under the Apache 2 license, so it is free for anybody to get and modify as they will. But there are things like trademarks and logos and brand management and that sort of stuff, and that's where the foundation really comes in. They also do things like put on the OpenStack summits every 6 months so that they can get developers together from all over the world to talk about what they want to happen in the next 6 months of development. And they do a whole lot of local events as well. I founded the local meetup here in RTP for OpenStack, and they actually, for OpenStack's 4th birthday, bought us all beer. So we like that pretty well. So membership is free for individuals. Companies can sign up as platinum, gold, or corporate memberships. So there's a couple different tiered membership levels depending on how much money you want to go put into the pot to support the cause. There's a board of directors that comes from those different tiers. So the platinum members all get a seat on the board of directors. The gold members elect several seats. Then there's some others as well. The technical committee is really what's in charge of the actual technical direction of the software. So again, the board of directors is really more about managing OpenStack's sort of intellectual assets and putting on summits and those sorts of things. The technical committee is where the technical guidance comes in for how the software works together. So for example, part of the technical committee's charter is to make sure that Project A in OpenStack is moving in lockstep with Project B so that they don't come up with a release date that the two don't work together. That actually happened early on in the OpenStack lifecycle, and we decided that was a bad thing and we should fix that. So the technical committee are actually elected by technical contributors to OpenStack. When you get a commit merged into OpenStack, you become what's called an ATC, or an active technical contributor. And among other things, that gets you the right to vote on who you want to lead the project going forward from the technical front. So this is very much a community that's centric on active contribution and giving voice to those people who are actually making a difference and not just talking from the sidelines. And I'll mention that ATCs come from a lot of different backgrounds. We have a lot of ATCs whose contributions are actually in the documentation space. So we actually manage documentation in OpenStack almost like we do code. It's actually in a code review system. It's actually auto-generated. And you can actually put a commit in on documentation, and that gets you an ATC badge. So even if you're not a software developer, there are plenty of ways for you to contribute to OpenStack. We'll talk a little bit more about those later on. Program technical leads, each project within OpenStack has, each program within OpenStack has an elected technical leader for that project for each release cycle. So that's a 6-month term. And those guys, again, are elected directly by the ATCs for that release cycle. So they're kind of in charge of helping steer that project for one release cycle through making technical decisions and kind of organizing people and assigning tasks to folks that are looking for things to do and so forth. There's also a user committee. This is a newish development. It wasn't always there. It's been there for several years now. But the user committee is really centric to giving voice to the users of OpenStack so that we don't just have a bunch of people writing code that don't really have a base with the actual people that are consuming that code. So that committee is made up of folks who are actually deploying OpenStack in the real world. Some of them at pretty large scale. So I think the current chair of that committee is still Tim Bell from CERN. Big science lab over in Europe. So they have a very large OpenStack deployment, and obviously when they have concerns or things that are going wrong in the software, they would love to have a voice to go before the rest of the OpenStack technical committee and even sometimes the board of directors and say what they think should happen. So they're kind of the voice of users. A bunch more details. These are links you can click later on when you get the slides. Oops. Corporate community makeup, I mentioned some of these earlier. There are a whole bunch of companies out there. They come from a lot of different backgrounds. They're vendors, they're users, they're people who put stuff on top of OpenStack and below OpenStack. really, at the end of the day, pretty much every major IT player that you can name is probably involved in OpenStack in some way, shape, or form, including some that people find surprising. I'm not really sure why these are surprising to some people, but every time I pull up these logos, people are like, really, those guys are involved in OpenStack? And they actually are. So Microsoft, for example, don't they have that Azure platform? Doesn't that kind of compete with OpenStack? Well, it turns out some people actually want to run OpenStack on top of Hyper-V. So doesn't it make sense for them to kind of support that, because then they can sell more Hyper-V licenses, right? And that's exactly what they do. Oracle, Citrix, VMware, VC, they're all there. So this is, like I say, a pretty big swath. When you're building a platform on which you can offer differentiation in a lot of different ways, it actually makes sense to cooperate. And that's part of the strength of OpenStack, is that we've attracted a whole lot of people from a lot of different backgrounds. So who's not in? Almost nobody, worth mentioning. Probably not strictly true, but again, when you're building a platform that changes the dynamic in the IT industry and gives everybody else a chance to compete on their merits, either under the stack or on top of the stack, it's a pretty attractive thing for people to come and collaborate for. And that's why you've seen the big growth. So the time for OpenStack is pretty much now, if you haven't guessed by now. So this came from, I think, an IDG study. And this was actually, I think this is now almost 2 years old. And in this survey, almost 84% of enterprises that they surveyed were talking about using OpenStack in their future plans. This number varies a little bit every time I see a new one, but it's always like way up there. So we're talking about 8 or 9 out of 10 almost every time. So this is something that a lot of people are definitely looking at. And interestingly, almost nobody actually says, I'm absolutely not going to look at OpenStack. So it's definitely something that has come a long way. So back in 2012, people were actually kind of getting nervous about OpenStack because it had all this hype around it. It had all these contributions coming in from all these different companies, and they kind of step back and say, is this really sustainable? Can all these people actually collaborate together, or is this going to devolve into a lot of infighting? So in 2012, Forrester were actually kind of warning that, OpenStack, you really need to get things together and keep people excited, or this whole thing may just fall apart. This is spring of 2014. Same analysis firm. So obviously things have come a long way. Even for some of the doubters in the early days, the things have really turned around. All right, so community participation. Lots of ways to get involved. So we do have IRC channels and mailing lists. So your typical things, if you want to ask questions, there's an operators mailing list, there's a developers mailing list. There are a whole bunch of sort of mailing lists for different interests within OpenStack. And also IRC channels, so you can actually go talk to people in real time. And people on IRC are actually pretty friendly and pretty helpful, I find. So if you have questions, both good resources to use. There are local meetup groups. We'll talk a little bit more about that in a second. There's Twitter, there's Facebook, there's LinkedIn, all the usual things. If you actually want to go get the code, we can look that up in Cgit. It's also mirrored on GitHub. We keep our bugs in Launchpad, so those are all places that you can go and actually see what's going on, get a sense for what's going into OpenStack lately, what problems people are facing, and what's coming up in the next couple releases. We currently record all our blueprints on Launchpad as well. Blueprints for OpenStack are kind of like definitions of what a feature is going to be, so that people are on the same page before they actually start writing the code. And a great way to get involved in OpenStack is to go review blueprints. So blueprints actually get reviewed just like code does, so that people are kind of all coming to a consensus before we go write something that nobody wants. And this is something that I find is really helpful as an entry point for people that are interested in contributing to OpenStack, because you actually get a sense for how things are being built. And there's a lot of common themes that come out on that over time. So those are stored in Launchpad now. A lot of the projects have actually shifted those into Git proper now. So we're actually doing spec reviews in Git and actually really doing them as code, which makes it even easier to actually pick them apart and comment on individual pieces. And there's also a new thing called Storyboard coming up in the future as a tool to replace Launchpad for some of the project management stuff. Not there yet, but something to keep an eye on. That's kind of an interesting corollary. OpenStack actually produces a lot of software that doesn't actually go into running clouds. So it's things like some of the stuff that they do on the OpenStack infra team for continuous integration and continuous deployment. It's things like Storyboard. There's a lot of other stuff that's generally useful to anybody who's developing code that comes out of OpenStack, which is actually pretty cool. 2 annual design summit conferences. I said there was a 6-month release cycle, and at the end of each one of those, we all get together and find out what we're going to do for the next 6 months. So those are a lot of fun. The next one is in Paris in a couple of weeks, so hope to see you all there. And again, local meetups. A lot of people are from the Raleigh area, so just so you know, there actually is one here in Raleigh, and there's a link to it here. This is a shot from our 4th birthday party celebration. Like I said, the foundation actually bought us all beer, so we all went out to a bar and had a big party, and it was lots of fun. Generally speaking, though, we actually come together for pizza and technical talks. So we have talks about networking, about storage, about how to deploy Open Sac, all those kinds of things. And it's a pretty wide swath. I think we have about 450-ish members now who are users, who are developers, people whose day job is Open Sac, and people who have no idea what Open Sac is and are just interested in finding out more. So why Open Sac now? If you look up there in the upper right-hand corner, these are the results of the biannual user survey. The OpenStack User Committee actually does a survey that usually the results come out right around the time of the OpenStack Summits. So this is one of the more recent ones. And when they ask people why they're interested in OpenStack and what's driving them toward that for their businesses, these are the kind of things that are interesting to them. And again, we'll have a new set of these coming out here in a couple weeks, so keep your eyes peeled for that. So you'll notice that one of the things near the top of that list is cost savings. Just to give you an idea, we all know that open source is not always free, right? The code itself may be free, but there are costs to operating open source software and integrating it with your other things, and sometimes you're supporting it yourself. So there are costs associated with it. That said, this is a case study done by the Open Sac Foundation. They actually had a top 10 auto manufacturer who is doing some campaigns, and we're actually able to shave some pretty substantial costs off by switching to OpenStack. So there's more details of this case study out at the OpenStack Foundation website, and I encourage you to go check that out. And on that note, we should probably also note that when we think about OpenStack, generally you think about cloud computing, because that's what it fundamentally is, right? But we've kind of gotten to the point now with OpenStack where it's a mature enough platform where that's not the only thing that you hear about with OpenStack anymore. The days of it just being about cloud are pretty much over already. And there's probably no better example of that than at the last OpenStack Summit in Atlanta about 6 months ago. The guy up there whose image is being projected in front of 4,500 people is a guy named Toby Ford. He's a vice president at AT&T, and he was up in front of everybody at a keynote talking about network function virtualization and using OpenStack as a platform to do that. So if you're in the networking space at all, then you probably have heard of NFV. It's another one of those big buzzwords that's caught a lot of attention lately. And it turns out a lot of people are actually interested in using OpenStack as a way to do that. So a pretty significant thing. That was the first time NFV has ever shown up in a keynote. Usually we have people up there talking about what they're doing in cloud computing with OpenStack. But this is a bit of a different use case. That immediately caught the attention of some other well-known folks in the OpenStack space. That's Russell Bryant. He's the former PTL for the Nova project at OpenStack. And also the chief scientist at Brocade immediately kind of latched onto that as well, and they're all pretty excited about that as well. So on that note, shameless plug. So just earlier this week, in fact, we got Toby Ford and Russell Bryant, Chris Wright, and a few other folks from the OpenStack community together and actually did a Google Hangout. Where we talked about OpenStack as an NFV platform. Not as a cloud platform necessarily, but as an NFV platform. And that is recorded for everybody to go see. So there's a link here. You're encouraged to go check that out. That's actually something we're doing periodically now, about once a month or so. Not on NFV specifically, but on a variety of different topics. NFV just happened to be the first one. So you may want to keep an eye out for that in the near future as well. All right, so let's talk about software. So this is a diagram that comes from the OpenStack Foundation website. Kind of gives you an overview into very basic categories. There's a little bit of nuance in here that this kind of abstracts away. So project names. Nova, Neutron. Nova is the compute engine. Neutron is the networking engine. Keystone is the identity service. Glance is the image service. Heat's the orchestration service. And it just kind of goes on and on and on and on. There's more and more. In the Juno release, I think we're up to like 11 integrated components now. So this is a project that is expanding pretty fast. These diagrams kind of become hard to keep up with after a while. Just for those of you that come from an Amazon background or maybe familiar with the AWS platform, a few corollaries here in green. Horizon, for example, is sort of analogous to the AWS management console. It's the web interface where you can go and do things like spin up VMs and create networks and those sorts of things. Cinder and Swift are the storage components over on the right-hand side there, similar to EBS and S3. And Neutron similar to VPC, Nova obviously pretty similar to EC2. So let's break that down and go one by one and kind of talk about some of the components that are in the latest integrated release of OpenStack. Nova is the one that I mentioned earlier, is one of the oldest components. This is what came out of NASA originally. Nova is the compute controller for OpenStack. So this is the thing that when you actually say, I need to spin up a new instance, this is the thing that takes care of finding some physical hardware to run that on, spinning it up, connecting it to a network, and giving it back to you to go use. So very similar, think very similar to Amazon EC2. Like all OpenStack components, it has a REST API. There's also a CLI client that we publish to interact with that actually uses the REST APIs. And you can also interact with it via the OpenStack GUI as well. Almost every component of OpenStack, with a few exceptions, is some kind of abstraction layer. So in Nova's case, what it's actually abstracting is physical compute resources and hypervisors. So for example, it is actually possible to run an OpenStack cloud with multiple hypervisors under the hood, and the user doesn't actually know it. So I could be running Xen and KVM, or KVM and VMware, or some other combination of hypervisors under the hood for different purposes. There are ways to schedule instances in particular areas if that's what you want to do, but it is actually possible to run homogeneous or heterogeneous hardware and heterogeneous hypervisors under the hood here, which is pretty cool. Multiple hypervisors, a couple different networking models included here. Originally when Nova came out, we didn't have a dedicated networking service like we do today. So there's actually some legacy networking models available in Neutron itself that are fairly dumb, but fairly reliable. So a lot of people are actually still using those if they got started Sac early on. Distributed asynchronous architecture, security groups are kind of worth mentioning. This kind of spans the gap between the networking pieces again. But basically, there are ways to do tenant isolation within OpenStack. Because keep in mind, when we're building clouds, a lot of these clouds have many tenants, and those tenants don't necessarily want to be interfered with by each other. So there are ways to isolate them from each other, including things like managing IP tables rules. And when we talk about Neutron, we'll talk a little bit about some of the other mechanisms for doing that as well. Glance is the image service. So basically, when you want to spin up an instance, you probably want to spin up, say, Ubuntu or Red Hat or CentOS or FreeBSD or whatever floats your boat. The way we do that is that you upload an image into a service called Glance. Then you can spin up as many instances of that as you want. So again, as an abstraction layer, what it's actually abstracting here are various containers, container formats, and image backends. There's a variety of them that are supported. For the storage backend, where those images actually reside, once you upload them into the cloud, you can keep them locally on disk. You can keep them in Swift, which is the object storage piece in OpenStack. You can keep them on Ceph. There's a couple other storage mechanisms as well. So again, that's one of the kind of layers of abstraction here. The end user doesn't really have to care. But as a cloud administrator, you may have opinions about what you want to put that on. Multiple container formats as well, OVF, QCOW, all the different container and disk formats. I will say that depending on your storage backend, there can be some limitations on which of those work. Like if you're running Ceph, for example, and doing Ceph back instances and Ceph behind Glance, then you're probably going to want to stick with raw images for now, due to some technical limitations there. Keystone. So Keystone is the identity piece of OpenStack. Really, this is kind of what takes care of Auth-N and Auth-Z. So this is kind of your central service for doing authentication and authorization. And it also kind of serves a service catalog function. So basically, I can send a query to Keystone, and once I'm authenticated, it will tell me where the endpoints for all the other APIs are. So that way, I know where the Neutron, if I want to send a request to Neutron or to Nova, it actually has a catalog that tells me where to send that stuff. A host name and a port and a URL and all those sorts of things. It provides the management of the Auth tokens. There's a couple different formats of tokens possible, including signed PKI tokens and pretty simple UUID tokens as well. And again, as an abstraction layer, what it's actually abstracting here are different authorization backends. So I can actually have all the authorization, all my user data sort of kept in a database on a backend. Or I can keep that in, say, an LDAP server or an AD server. So especially when you get into the enterprise use cases, a lot of people like to back this with AD or LDAP, because that way they can integrate with an existing directory server. Cinder is the block storage piece of Open Sac. So this is what's going to provide persistent block volumes. When we talk about instances in a cloud, generally when you terminate those instances, they kind of go away, including all the data that was on their local disks. And that's a great use case for a lot of folks. It's the way most clouds operate today. But a lot of times people actually have data they want to keep around, right? Not surprising. So OpenStack block storage is kind of the answer to that. Basically what this allows you to do is attach a block volume to your instances, write data to that, and even after the instances go away, that volume is still persistent. And then you can go attach it to another instance later on, or move them around, or so forth. You can do snapshotting and all that kind of fun stuff there as well. So again, similar to Amazon EBS, several underlying block storage components here. Again, this is abstracting what the actual physical storage is. You can actually run this on local disk with LVM. Not a very redundant way to go, so probably not what you want to do in a production deployment. But you can also do things like all your traditional storage appliances. Most of those have drivers now. Some of the newer ones as well, like Ceph, for example, is a distributed storage system that uses commodity disk. So a lot of different backends possible. And again, whoever the application is doesn't actually have to care about what that backend is. All they have is the interface to the API, and they're good. I should also mention this is kind of an evolution of OpenStack in that the block storage piece actually used to be part of Nova itself, and it was split out over time so that the two could be developed independently, and people could focus on kind of the individual aspects of those. And that's something that we actually see happening fairly often now. There's a lot of conversations about things that could be split off from other services. We'll talk a little bit more about that with Neutron. Object storage. So object storage is a little different from block storage. This is not give me a disk on my machine that I can put a file system on. This is where you're actually storing, say, a file, for example. Think of it a little bit more like sort of like a Dropbox situation, where you're going to put a file somewhere. And you can do things with those objects. Not necessarily all files. They could be arbitrary chunks of data. But most people kind of think of them as files. But you can do things to those objects that you're storing, address them with an API call. That's actually stored in a distributed fashion, a little bit similar to, say, Hadoop's HDFS. So basically, it's going to propagate copies of that object to multiple machines in the Swift cluster on the back end. There's some pretty cool stuff in here as far as being able to span multiple data centers and even multiple geographies. So there's been a lot of work on making this scale really pretty well. Often this is actually run on bare metal. So when you think of cloud, you often think of virtualization. This is a piece that's basically just about the storage. So this often gets run on bare metal because adding a hypervisor doesn't really buy you anything here. And Neutron. So Neutron is the networking service for OpenStack. This basically started out as a layer 2 connectivity solution and has since graduated all the way up to the top of the OSI stack almost, or so it seems anyway. There's L3 functionality now. You can actually create a router in Neutron. And you can actually do things like firewall as a service, VPN as a service, load balancing as a service, which kind of starts to wander over toward the NFV space that I was talking about earlier. What else do we want to say about Neutron? So kind of some interesting evolutions with Neutron. Neutron started off as a completely separate service. So it was actually developed in parallel with the old Nova networking models for quite some time. And there's been debate in the community about whether that was a good idea or not. A lot of people felt maybe we should have kind of started with what was in Nova and split that off as a separate service rather than starting a whole new parallel code base. So it's kind of an interesting result of that. There are actually still Nova networking models that you can use today. They're pretty much on the path toward deprecation. In fact, they've actually been deprecated and then undeprecated at least once already, while more Neutron features kind of matured. But generally, if you're starting with the cloud today, you probably want to be looking at Neutron because it is pretty clear that Nova networking is going away eventually. It's mostly there because people are still actually using it today, and we have to get to a place where we have a clean migration path for those people before we kind of rip it out of the code base. So kind of interesting things you can do with Neutron. When you think about being in cloud, one of the kind of interesting use cases for cloud is like web apps, right? So I want to spin up a set of load balancers, a set of app servers, a set of database servers. And in a traditional sort of non-cloudy design, you would think of those as being in separate networks, right? So you don't necessarily want to expose your database servers directly to the internet. right? Those are going to be front-ended by the app servers or the load balancers. Traffic from the internet is going to come into those and then eventually filter back to there. But your database servers aren't going to be exposed directly to the internet. Neutron allows you to do that in a cloud. And allows you to do that on demand as a tenant, not as a cloud administrator. So I can actually go into Neutron and say, I want these 3 networks, and then I'll put routers in between them and have it route packets between them as necessary. And I can choose which ones I want to expose to the outside world and which I don't. So this allows you to actually build tiered applications like that in a cloud as a tenant on demand, which is pretty sweet. Ceilometer. So Ceilometer is the telemetry service. This is basically what's feeding information about what's going on in your cloud to a central source. Originally designed for billing, kind of provides some other insights as well as far as kind of performance of your cloud and resource utilization, even capacity planning to a bit. This is still a fairly young project, has a few blind spots and a few scalability issues. This thing produces a lot of data. So you really want a robust database backend when you're dealing with Ceilometer if you're going to turn on all the features here. Orchestration. So another one of the fairly newish components in OpenStack. This actually provides an orchestration service for when you want to set. So let's back up. So I talked about the 3-tier application architecture that we had earlier. If I want to spin up a web app, I want to have disconnected networks and those sorts of things. What Heat actually allows you to do is orchestrate the provisioning of all that stuff. So as an orchestration service, that makes a lot of sense if you want to deploy applications in a cloud. Kind of similar to AWS's CloudFormation, and we actually have the ability to use CloudFormation templates, but it also has its native templating format called Hot. Frequently used as an auto-scaling service. That's probably the most common use case for this. Basically, as load increases on my app servers, I want to spin up more app servers to absorb some of that load and scale horizontally, and then scale back down afterwards as well. Database as a service, this is the newest integrated component in OpenStack. This just became integrated in the last release, maybe the release before, I'm forgetting. Trove is basically database as a service. So if you think about the kinds of applications that people put in clouds, how many of them have a database backend? An awful lot. So in a sense, databases almost become part of the underlying infrastructure almost as much as servers and networks and routers, right? So from that perspective, the community started looking at doing database as a service and actually providing a service where on demand you can spin up instances of databases. So again, kind of an abstracted backend. You don't really have to care what the underlying backend is, although as an administrator you may have decisions to make there. But it saves people from going through that whole tedious setup process of creating, set up an instance and then put MySQL on it and then set up replication and do all these other things, right? So the idea is to make getting a database much, much easier. And also to make it elastic. Databases are often used to persist data, but that doesn't mean they're going to persist forever necessarily. You may have a temporary 3-month marketing campaign, or maybe you're just doing some big data analysis, and once the data set's analyzed, you don't need it anymore. So again, you can spin this up, spin it down. And lastly, Sahara. So this is basically Hadoop as a service. And I say Hadoop as a service, but actually they have Spark drivers now as well, which is kind of neat. So kind of the same concept as the database side of things. Big data is a huge use case in the cloud right now, especially for people who don't want to build out a massive big data cluster that they can't keep busy 24/7. Because the workloads that they have are bursty. Think maybe end of quarter analysis or those sorts of things. You're going to be using that big cluster 100% utilization, but only for 1 week every quarter. So that's a lot of hardware to invest, right? If you do that in the cloud, then you spin those instances up when you need them, spin them down when you don't. You get billed for what you actually used. So Sahara is actually kind of along the same lines as the database. Hadoop has become such a fundamental building block of applications in the cloud that there's now actually a service to make that easier for you. So you don't actually have to do all the manual process of setting this up. Supports different Hadoop distributions on the back end, actually has hooks into some of the management tools as well for those different distributions. So cool thing. There's more. So besides all those integrated core components, there's a whole lot of other stuff that goes on at OpenStack that's pretty fundamental to the operation of OpenStack. So we have supporting projects like documentation. We have the infra team that handles all the continuous integration infrastructure that we use to develop OpenStack itself, which is a huge undertaking. And I'll talk a little bit more about that in the next talk. We have common library projects so that almost all of these OpenStack components use an RPC bus to communicate with their processes internally. It would be really great if we didn't have to design that over and over again for every new OpenStack component. So there's a common library called Oslo where that code lives. And then all the components can rely on that common library. We have gating projects like DevStack and Tempest. DevStack is a very fast way to get a development environment set up to where you got the latest code, or older code if you want, but get the latest code so that you can actually make changes and then submit things back upstream. And we actually use that to run some of the gating tests as well. Tempest is actually an integration test piece. And that one on the right should not have been there because most of those are not incubated anymore. Some of those are graduated. Some other things that are coming down the pipe, just to give you a taste. Barbican is a key management service. Ironic is bare metal as a service. Kind of take the hypervisor out of the picture for workloads that actually want to run directly on bare metal for maybe performance reasons. There are a whole lot of others as well, which I'll talk a little bit more about later. DevStack, if you're brand new to OpenStack and you just want to get a development environment set up to where you can see things actually working and then I go hack on the code and see what happens, DevStack's usually the way to go for that. Basically, it is a bash script. It's kind of a complicated-ish bash script nowadays, but its basic task is to go out and get all the code from the repos, spin it up, and actually start those services running on your local machine so that you can kind of have an all-in-one integrated environment to get started developing with. Do not run this in production, please. There are good reasons for that, which I won't bother to get into today, but just know that this is a good way to get started if you want to go mess around with things. It is not a good way to go to production. OK, so things you need for OpenStack itself, a hypervisor, except when you don't. Like I said, you can actually run on bare metal, or you can actually run on container technologies. LXC has been supported in OpenStack for quite some time. There's a hypervisor comparison chart that I've got a link to here that kind of tells you what different things are supported on all the different hypervisors. Obviously, it's some have different capabilities than others, and we've exploited those in different ways in Nova. You're going to need a database on the back end. Most people use MySQL. You can also use Postgres or other databases as well. All the OpenStack components use SQAlchemy as an ORM layer in Python, so we actually have a layer of abstraction between us and the actual databases. You're going to need a message queue. So OpenStack components communicate with each other via APIs. But within those projects, for example, when the Nova API wants to talk to the Nova scheduler, that's usually done over an RPC bus. And that RPC bus is usually RabbitMQ or Cupid. There's been some work. Some of the components actually support 0MQ now as well. Not all of them do. So it's kind of in sort of a flux state. But generally, what we see most often is RabbitMQ. You're going to need hardware. Obviously, you need servers. You probably want some networking gear. You may want some storage gear. Don't necessarily have to have anything beyond local disks in your servers to get started. But all those things are important. And then Python stuff. OpenStack is written in Python. There are some other languages. So for example, Horizon has some AngularJS components. Obviously, there's CSS and HTML involved there as well. But OpenStack itself is written in Python. A couple libraries we use. Django is actually kind of being removed now. We use EventLib, we use SQAlchemy, some of the common Python libraries. If you're a Python programmer, this is all going to look pretty familiar. Some things we've learned over time in OpenStack. So sometimes putting your best foot forward means putting your code where your mouth is. In the early days, there were a lot of people who had a lot of opinions about what OpenStack should be doing. And then some of them didn't show up to write code. Guess which ideas got implemented? The ones who actually showed up to write code. So be prepared to actually get in there and get your hands dirty. It's a pretty accepting community. Don't be too sensitive about your code reviews because we're trying to keep a hold on thousands of developers here. So we are picky at times. But this is a pretty accepting community. There are a lot of novice programmers who've been able to get code into OpenStack because it's a pretty accepting community, and there are people who are willing to guide you through the process of becoming a contributor. There are actually OpenStack ambassadors as well, who one of their kind of functions is to help people get involved in OpenStack. Things move really, really fast in OpenStack. You saw the specs that I threw up earlier. 4 years, tens of thousands of people working on this across basically the entire world. I think we've even seen downloads in Antarctica now. So it's pretty crazy. Things move pretty quick, so it can be a little bit overwhelming if you're new to the community. My advice is really find the thing that's interesting to you. There's a whole lot of things in OpenStack. Some people really care about storage. Some people really care about networking. Go find those things and pick on those a little bit, and then you can kind of gradually expand your horizons. This is going to feel different for some of you. People are not always used to projects moving this fast. They want to put something in their data center and leave it for 3 years. This is not the project for you. This is a project that moves pretty quick, but it's like I say, a lot of fun, even though it is pretty quick. All right, so that's all the basics I have for OpenStack. There's going to be a second talk in this room about how to actually manage a cloud once you do get it started, and things that you want to take into consideration when you're actually getting ready to go to production or even to the proof of concept level for OpenStack. So I'm happy to take questions, or there's my Twitter handle, and I'll be around afterwards as well. Anybody?